Hello, and welcome to today's Safety and Health webcast, Achieving Electrical Safety Compliance in the Workplace, sponsored by Salisbury by Honeywell. My name is Kyle Morrison. I'm the Senior Associate Editor with Safety and Health magazine, and I'll be moderating today's session. I want to thank you all for joining us. We'll start the presentation in a few minutes, but first I'd like to go over some housekeeping items. The views of the speaker and his organization are his own and do not necessarily reflect those of the National Safety Council or Safety and Health magazine. Mention of any commercial enterprise, product, or publication does not mean the Council or the magazine endorse them. At the end of today's webcast, we'll have a question and answer session. To ask a question, simply type it in the text box located in the lower left-hand corner of your screen, then click the Submit Question button. Feel free to ask your question at any point during the presentation. You don't have to wait for the Q&A session to start to ask your question. Be aware that we do have a large number of attendees today, so we may not get through all of the questions. However, any unanswered question will be forwarded on to today's speaker. For basic troubleshooting information, please click the Help button located on your screen. At the end of the webcast, you'll be asked to complete an evaluation survey, and I'll talk a little bit more about that after the presentation concludes. This webcast will be archived for 3 months. You can access it after today's live presentation. Just simply use the exact same URL that you used today to return to the archived version. And with that, I think we're ready to begin. Our speaker today is Brian McCulley. Brian is the business leader of electrical safety at Salisbury Assessment Solutions, a division of Honeywell Safety Products. He oversees business in an emerging market for customers seeking solutions for electrical safety needs. Brian?
Hey, well, thank you very much, and appreciate the time today. So good afternoon to the folks on the East Coast, and good morning to the folks on the West Coast. I guess what I'll do is I'll go ahead and take us through an agenda, but first and foremost, on behalf of the NSC and Salisbury by Honeywell, I want to thank everybody for taking the time today. So as you see in front of us, the agenda that we'll cover today is electrical safety basics, arc flash statistics, OSHA and NFPA 70E, and really what does OSHA say about that at the end of the day, NFPA 70E, written electrical safety programs and policies, importance of an electrical assessment, the importance of electrical training, and then finally, electrical personal protective equipment. So just starting out, what I wanted to do is take a little bit of time to talk about how this profession, which is the electrical industry, has changed over the last few years. And I went back a little ways. As you can see, this book that you're going to see is from 1942. So this is actually the American Electrician's Handbook. So if you were an electrician back in 1942, this was the book you were using, and these were the policies that you were actually following. So if you look at section, that may be really small to read, but section 90, it actually says, and keep in mind, this is 1942, so this is ways back, electricians often test circuits for the presence of voltage by touching the conductors with the fingers. This method is safe where the voltage does not exceed 250 volts and is often very convenient for locating a blown out fuse or for ascertaining whether or not a circuit is alive. Now this is the part that really gets me. Some men can endure the electric shock that results without discomfort, whereas others cannot. So amazing to think back in 1942, this was the way that people actually handled electrical safety. And now it gets better. If you look at section 91, the presence of low voltage can be determined by tasting. This method is feasible only where the pressure is but a few volts. And if you move just down a little ways, where the voltage is very low, the bared ends of the conductors constituting the two sides of the circuit are held a short distance apart on the tongue. If voltage is present, a mildly burning sensation will result, which will never be forgotten once it has been experienced. So believe it or not, back, 70, 75 years ago, this is the way people would work on electrical applications. So thank goodness we've come up with things today that make our electrical workers much more safe in the field. And whether that's practices and policies and applications and even products that's keeping those folks safe, we've come a very, very long way, as you can see. So really, at the end of the day, what are the electrical hazards that we need to be very much aware of? Well, there's electrical shock, and that's really the electrical current that enters and exits the body that creates a path. Then you've got arc flash, and that's just a dangerous condition associated with the release of energy caused by that arc. So this can include a broad spectrum of electromagnetic energy, plasma, fragments, and the spray of molten materials. This really is your igniter if you're not wearing the proper PPE from a clothing standpoint, and we'll talk a little bit about that as we go. And then you've got the arc blast, which is really that pressure wave caused by the expansion of gases and conducting materials with flying molten materials. So all three of these are very, very hazardous, and they all have a lot to do with each other. But we've got to be aware of each and every one of them because they all cause different hazards to our electrical workers. So moving to the next slide here, we'll just kind of illustrate the current passage and how it actually goes. I mean, you've really got touch potential, you've got step potential, and then you have touch and step potential. See a couple of examples there on the right side. And as I think we all know, current that passes through the heart and lungs is to be taken the most serious. That's unfortunately where we see a lot of injuries and unfortunately fatalities as well. So you need to be cautious of any type of current going through the heart and lungs. Now when it comes to the effects of shock on the body, it's really current, not voltage, that causes electrical shock. Now I know a lot of folks on the phone have heard of Berkeley University out in California. So we ought to thank them for this slide because what they did in the 1950s, I was told, they actually wanted to understand how much from an amperage standpoint that the human body could take. So what better way of doing that than to maybe get some students that attend your university to volunteer, and that's exactly what they did. So some workers actually, students actually volunteered, raised their hand, and as you can see this individual's picture here on the far right, he's probably wishing he wouldn't have volunteered because he's got 10 plus milliamps going through his body at this particular moment. And then you can see what happens with respiratory paralysis at 30 plus milliamps, heart paralysis, which may be fatal at 60 plus milliamps, and it just gets worse and worse from there. So the more amperage you're putting on the body, the more strain and the more possibility that there's going to be a higher injury or potentially a fatality. So as we move into the next slide, and the question that I get all the time is, what causes an arc flash? And, you know, there have been studies that have taken place in certain facilities where arc flashes have taken place, and the studies really didn't turn up a true reason. So, you know, and sometimes there could be, you know, somebody may drop a screwdriver. You know, I've heard stories where people have left a screwdriver on the top of a cabinet at the end of first shift. An electrician walks up to that cabinet at the beginning of the second shift, and I think you know where this is going. They open up the door to continue the work, but the screwdriver falls down and it causes an arc. So, you know, these things can happen in many different ways, but really at the end of the day, the reason is that as we know, electricity will go through the path of least resistance. So when the path of electricity is suddenly interrupted, the electricity will create a new pathway. Unfortunately, that's when you get the arc flash. So these can really be generated by mechanical breakdown, failure, current overload, or accidental contact. Now, the impacts of an arc flash are extremely severe. As much as 80% of all electrical injuries and burns result from arc flash and the ignition of flammable clothing. So it goes back to the earlier statement I said in the arc flash. The most injuries that we're going to see actually happen when somebody's not wearing the proper PPE. What ends up happening is that 65-35 polyester cotton blend goes up in flames, and it's just really difficult to stop, drop, and roll and put that fire out quick enough to avoid third and fourth degree burn injuries. So unfortunately, we're seeing injuries by people not wearing the proper personal protective equipment when these occurrences do happen. And the funny thing is, you know, we've seen probably videos and you know, Google, YouTube have fantastic videos of arc flashes taking place. Some of these are 30 cal, some of these are 50 cal, but it only takes 1.2 cal to give the human body a second degree burn on human skin. So it doesn't take that much energy to cause a second degree burn. So imagine how that multiplies as you get higher with the cal ratings. Arc temperature can actually reach 35,000 degrees, 4 times hotter than the surface of the sun. So imagine that if you're an electrician working 12 to 18 inches away from that equipment, and in less than a second, 35,000 degrees potential heat is overcoming you. And then fatal burns can still occur at distances 10 feet and over. And this has happened quite often where stories are reported where maybe supervisors are staying away from the equipment, but they're not aware of what those minimum approach boundaries are, and they are just staying too close and not wearing the proper PPE, and an accident takes place, and then you've got an injury or potentially even a fatality. Now, the thing that stands out a little bit here is 2,000 people are admitted into burn centers each year with severe electrical burns. Now, these aren't just burns that happen in the field, you know, based on electrical applications that are minor. These are severe. So, you know, I wouldn't wish this on my enemy. I mean, folks on the phone probably know people who have been in burn centers. It is not fun. My heart goes out to anybody who's been through something like this. But they're also not only very difficult for the individual going through it, they add up from a dollar standpoint extremely, extremely expensive. So you can have someone in a burn center, and it could be $10,000 a day just to keep them in that burn center. And that's not including the surgeries and the skin grafts and things like that these individuals have to go through to try to help them and try to maintain, that limb or a certain part of that body. So these can be very expensive, and we'll talk a little bit more about that as we go. Now, the arc blast is a different beast in the sense that it can create a blast in excess of 2,000 pounds per square foot. So it can easily move a human body across a 10 by 10, 10 by 12, electrical switchboard or panel room. And it's been reported many times where individuals flown right away from that equipment, and literally their body is thrown into that sheetrock, and you can see the body print within that wall. There's actually been electricians say, thank goodness for the arc blast. It pushed me away from the flash, and it lessened my injury. So it's just an enormous amount of pressure that is coming at you. But the problem with that is you do face exploding switchgear and molten metal sent out at high velocities. So if those hit you in areas on your body, that could be very much dangerous. That could be leading to a fatality as well. So again, another area that we need to be concerned with when it comes to the arc blast. So I threw up a little bit or a few statistics here for us to take note of. I'm going to skip down to the fourth one there. It says over the last 10 years, more than 46,000 workers have been injured from on-the-job electrical hazards. So that number is just incredibly high. And I think what it does is it just paints the picture that we probably need to do a little bit better job of making sure that our teams and our electrical workers are following the procedures and the written electrical safety programs that we have in place for those individuals that are out there in the field working. And if you go down to the fifth one there, medical costs, and we'll get to the point of how expensive sometimes, these burn injuries can be. Medical costs for severe electrical burns can exceed $4 million a person. And if you go down to the very last bullet, work-related injuries can cost businesses well over $30 million in fines. Now, for the folks on the phone, I'm sure you're thinking, how can it possibly be $30 million in fines? Well, once you get through the medical costs, which can easily exceed $1 million, potentially $2 million, then you may have a litigation on your hands where a family may be suing you for another $5 or $10 million. And I'm just throwing numbers out. Lost business. Let's say, for example, that you're in the oil business. I mean, every minute that you're down, or every 30 minutes or 1 hour that you're down, that is lost revenue, lost profitability. So you've got to calculate that in, and that can be very, very expensive. And then equipment costs. Let's say, for example, by not doing the proper maintenance or somebody just not following the proper procedures, an arc flash takes place. That piece of equipment could be a generator. Sometimes generators can cost $500,000. Not to mention there could be other equipment surrounding that generator or other piece of electrical equipment through the arc flash, arc blast, where damage would occur as well. Buildings could be damaged. So it could really add up at the end of the day. And to go back up to the top there, I know I'm going a little bit backwards here, but I want to hit note on those bottom ones first. A recent study, and I say recent, but it was from 1992 to 2002 from the National Institute for Occupational Safety and Health, which is NIOSH. I know we're all familiar with that. It came out in 1992 and 2002 saying that 17,100 injuries were caused by electric arc flash burns. Well, I think that's where NFPA really began to get, NFPA 70E really began to pick up a little bit of horsepower because you can see over the last 10 years when you go down to the 4 bullets below, that number's really multiplied. There's a lot more visibility to it at this point. Second bullet down, 97% of electricians have been shocked or injured on the job. I do these presentations all over the country, and it's funny because I do get a lot of heads nodding at me saying they'd love to meet those 3% that haven't been shocked. And I'm not even an electrician, and I've been shocked numerous times. So obviously that number is pretty high. And again, that just stresses to make sure we have the proper procedures and the proper policies and programs in place to keep our workers safe. And then the scary thing, every 30 minutes during the day, a worker suffers an electrically induced injury that requires time off for the job. So again, that's another little bit there that ties into that 30 million potential and just not having that worker there. Again, loss of productivity and that type of thing. So as we move on to this next slide, it's a little bit of a bar chart that just kind of paints the picture. 4,000 people have electrical contact injuries, and those are non-disabling. Another 3,600 people have electrical contact injuries that are disabling. That number is just way out of control. It's way too high. And then if you go to the third bar chart there, and the number that just disappoints me, it's sad, but 365 people are electrocuted. And when I say electrocuted, that means a fatality did take place. That means one person a day is losing their life due to lack of electrical safety, lack of electrical applications that may be out there. Again, it's a very important topic. And, we were talking about this earlier this week in Washington, D.C. We actually met with OSHA, and it is amazing to see the industry for electricians because that number is just really, really high. Whereas if you look at the firefighters and police and things like that, when they have a fatality, people know about it, and it's crosses the press immediately. But unfortunately, when electricians, go through something like this or there's a fatality, it doesn't seem like the media gives it a lot of attention. And it was interesting to hear what OSHA had to say about that as well. The final one, 2,000 workers are sent to burn centers each year with electrical burns. We kind of covered that one already. So I just gave a couple of examples here, and these are public articles that have come out. But what it does is it kind of just paints the picture. And I'm not going to read the entire article, but what it does is it just paints the picture of what OSHA is doing out there. Because at this point, it seems like they're really taking a proactive approach to some degree. But for years and years, they've been taking a more of a reactive approach. And what I mean by that is they would come in after an incident may have occurred, whether there's an injury, whether there's a fatality, whatever it might be, and then they would find the employee or they would find the organization at that point. But it seems like things are really beginning to pick up with OSHA in regards to a proactive approach. And on our website, which is actually arcsafety.com, every 2 weeks what we do is we go in and we update on the front page of that website the most up-to-date finds and activity that OSHA is actually out there doing within the industry. So if you ever wanted to kind of get an update on where OSHA was and some of the activity, what we do is we take public articles and we post them on our website just to educate our customers a little bit more, especially as it relates to OSHA and some of the activities that they have. But in regards to this article here, this is interesting in the sense that not only the organization was fined $160,000 for a violation, a supervisor was fined also $11,000 for the same incident. Now, this was actually a post incident, but if I go to the next example, this is actually before anything would have occurred. And so this is where OSHA has gone in and actually fined an organization for $55,000. And there's numerous examples in there where they might not have been meeting the right requirements, power press, electrical, and other hazards as well. But again, that was OSHA taking in just an example there of being a little bit more proactive in the sense of being reactive. So how do I get compliant? I mean, that's the question here that I'm going to attack at this point. And, here in front of us, we've got a couple of folks that may not be compliant, and not necessarily are these electrical applications, but I thought I'd take a shot at throwing these up there because the one on the left really is out of sorts in the fact that it looks like the individual swam to a metal ladder, has a power cord through the swimming pool that he just swam through, and he's obviously going to work there. And if you look in the background, he may have had a beverage of his choice on the way to that ladder because there's liquor bottles stacked up there. So interesting shot there. A lot of things need to be addressed with that photo. And then the one on the right, I don't even know if I have words to explain that, but somebody got very creative in accomplishing that task. Now, this is not electrically related at all, and maybe some of you guys have seen this clip on the internet, but I just had to show this one because these folks are definitely not in compliance, at least from a fall protection standpoint. So very interesting shot here, but they definitely got creative, that is for sure. So getting back into electrical safety, what is it that we need to be aware of? What is it that we need to make sure we're following to maintain our electrical compliance? Well, it really starts with these 4 standards and regulations. First, you've got OSHA 29 CFR 1910 subpart S. You've got the NEC. You've got NFPA 70E. And then you've got the various ASTM requirements. All of those together play a major role in overall electrical safety. And I know a lot of the customers that we've talked to in the past, they look at that and it's extremely overwhelming, and we understand that. So one of the things at Salisbury by Honeywell does its best in doing is sitting down with the customer, understanding what those needs are, so we can map out the best solution. So if you look here at OSHA 29 CFR 1910, and I'll just kind of read the high-level notes here of it, but really at the end of the day, 1910.303 requires employers to mark electrical equipment with descriptive markings. Additionally, and I'll go to the bottom there, OSHA requires employers to use alerting techniques, safety signs, tags, barricades, attendants to warn and protect employees from hazards which could cause injury due to electric shock, burns, or failure of electrical equipment parts. National Electrical Code 110.16, which is really the flash protection section, and I'm just going to kind of skip down to the bottom there just to save a little bit of time. But electrical equipment that is in dwelling occupancies are likely to require examination, adjustment, servicing, or maintenance while energized shall be field marked to warn qualified persons of potential electric arc hazards. Now, if we go to NFPA 70E, you'll see some similar statements in the sense there, but it's 130.5. Shall determine the arc flash boundary, the incident energy at the working distance, and the personal protective equipment that people within the arc flash boundary shall use. The arc flash hazard analysis, or what I refer to as the electrical assessment, shall be updated when a major modification or renovation takes place, and it shall be reviewed periodically not to exceed 5 years. So a very important point to remember, to account for changes in the electrical distribution system that could affect the results of the original arc flash hazard analysis. Nope, I'm sorry, I may have skipped that slide, so hopefully you guys got a chance to see that there. All right, so the labels at the end of the day, what they really look like, and this is a great example of a label here, through an electrical assessment or arc flash study or arc flash analysis, the deliverable here at the end of the day is these labels. So once the data is collected and the calculations are done, these labels get printed and they get put on the equipment. So what ends up happening at the end of the day is that electrical workers know exactly what the boundaries are by looking at the label. They know exactly what personal protective equipment is required when accessing that boundary or even accessing that equipment, opening up the panel, opening up a door of some sort. So these labels will put you in compliance in regards to making sure that your electrical workers are wearing the proper PPE or personal protective equipment each and every time they enter that boundary. So this is a good example of what that label actually looks like. So the question of the century is, and I get this question all the time, is, what is it that OSHA says about NFPA 70E? I get NFPA 70E. I understand what it's writing about. I understand what it says. But where does OSHA stand when it comes to NFPA 70E? Well, as I mentioned earlier, I was in D.C. on Tuesday, and we actually had Bill Perry, who is the Director of Standards and Guidance at OSHA. They actually have a facility pretty much almost next door to a Honeywell building that's very close to the Capitol. So after meeting with Bill, it was very interesting to understand some of the updates that OSHA is working on this year. First and foremost, they went through 4 major updates, and I think everybody on the phone understands they've been very, very busy the last couple of years, and it seems like things are beginning to come out of the funnel this year. And I think there's a lot of changes that are coming way, but one of them is Subpart V, and that is the electrical compliance. So David Wallace, who is really the brains behind these changes and these updates, and I believe his updates incorporate about 473 pages, but they came out April 11th, if I have my dates correct, so just very, very recent. But David Wallace really is the mastermind behind the electrical side within OSHA, and he works in the same building and works right alongside Bill Perry, who we met with on Tuesday. But if you'll go to YouTube, David Wallace has a YouTube video, and you can actually see this exact video, and the link is right there at the very, very bottom. But if you just go to YouTube and just put a search in for David Wallace OSHA, it'll come right up. But really, at the end of the day, what Mr. Wallace was asked was, what does OSHA look for, and when officers are in the field? Also, if issues are found where organizations lack compliance to NFPA 70E, are they enforceable? So the way Mr. Wallace answered that question is the following. We can cite an employer for 2 things. We can cite them for violating the needed PPE requirements listed in 1910. Also, we will enforce 1910.335, which states the needed electrical PPE to be required for electrical work and arc flash hazards. It must be industry practice to provide your employees this type of protection. We can look into NFPA 70E in some cases, and it looks like they actually have in the past, and Ford Motor Company was one that David actually referred to in the sense that the settlement agreement was Ford would adopt NFPA 70E in addressing its electrical compliance needed. So that was a few years back. Now, David actually summarizes his whole statement there and saying, you know what, if I was an employer and I wanted to get into electrical compliance, I would follow NFPA 70E. It's already a standard that's written, and it makes it much simpler and easier to adopt and adapt and implement. All right, so NFPA and OSHA. What does OSHA say about NFPA 70E? I think I just jumped ahead there, but you can see David's comment there about how he would recommend NFPA 70E. But at the end of the day, what is it that's needed? What are the programs, what are the policies that are all needed to maintain that compliance? Well, it starts with the written electrical safety program. That's your policies. That's your procedures. It's important to have that in place. You've got to make sure you have your electrical safety training program in place as well. An arc flash assessment, an electrical assessment, an arc flash study, an arc flash analysis, all really meaning the same thing. That needs to take place as well. And then the proper electrical personal protective equipment needs to be purchased, and most likely that will be on the tail end, so you know exactly what your energy levels are at that point, and you can make the best buying decisions for your electrical field. So, why was NFPA 70E written? So just a little bit of history here. Prior to 1982, it was really assumed that shock was the major risk associated with live electrical work, but really that's incorrect. And based on some of the studies and statistics we shared earlier, I think we understand that. According to a study by Dr. Ralph Lee, 80% of the electrical injuries actually resulted from the arc flash rather than the shock. So that's where we really begin to see some horsepower behind NFPA 70E. So the four criteria at the end of the day that OSHA is really going to pay special attention to is number one, it must be a recognized standard in the industry. Lockout, tagout, fall protection, NFPA 70E, they're all recognized hazards or standards, in the industry. Number two, serious injury or death could occur if not followed. So third-degree burns, life-altering scenarios, death, all can and do occur if NFPA 70 is not followed. So again, to back up David Wallace there, adopting a standard like that is a good thing. Employers must be at risk. Any employee with a multimeter energizing, de-energizing, or working live or working hot would be at risk. So we need to make sure those applications and those policies and the proper PPE is being worn to eliminate or mitigate that risk. And then finally, there must be an abatement method, PPE, tools, equipment, anything that can negate or abate the hazard must be in place. So, we'll talk a little bit about written electrical safety program, then I'll talk about training as well. But, when it comes to written electrical safety program, this is very key. There's a lot of corporations that we work with that have multi-sites. Some have 500 sites throughout the world. Some have 3 or 4 sites just throughout one state. But it doesn't make a difference how big or how small you are. Every site must be consistent with their electrical policies. And it just makes it so easy to drive it down from the corporate level to ensure full compliance throughout your entire organization. So it's important to have the consistency. It's important to have the proper documentation for your electrical applications. You also want to make sure you got electrical training requirements written in the electrical safety program. And you also want to make sure that the electrical PPE equipment or the personal protective equipment requirements are in place. So, a lot of people say, well, heck, can I do this assessment on my own? Because I've gotten a couple of quotes, and it just seems pretty high, pretty expensive. Can I do this myself? And the answer is yes, but it is quite an undertaking, and it is quite a daunting task. And the reason I say that is I'll lay out the variables that are needed to do the calculations. You need to know maximum fault current. You need to know voltage, arc gap, clearing time, the distance the electrician is working. You need to understand if it's a 3-phase or a single phase. You need to also take into accordance, are we talking about confined space? And it's important to understand the characteristics of the equipment. All those variables go in to making up the arc flash assessment and the calculation, which gets the energy level placed on that label, which is on front of that equipment, which dictates to that electrical worker what they need to be wearing when they access that panel. So can this be done? Yes. Software can be purchased, but there's a lot of work that needs to be done in understanding what that maximum fault current would be, what that clearing time would be, and you can see there could be some challenges internally. So yes, you can do it, but there's a lot of work that goes into it. So it's almost just as good to outsource it and to hire somebody that can do it for you. So as far as the electrical assessment deliverables, obviously it's something that Salisbury Assessment Solutions, which is the business that I run, does. But, whether or not you work with us or work with another competitor or do it on your own, I want to make sure that everybody is getting the proper deliverables. And one of the things you want to make sure everybody is provided when you do an electrical assessment is you need to make sure part of that deliverable is an updated one line for each site. So if you've got 3 or 4 buildings on your campus, you want to make sure you've got updated one lines as a deliverable from the electrical assessment for each one of those buildings. All deliverables should be in paper and should be in electronic formats. And the reason I say that is because we don't want these reports to be printed, run, and then sent out and either stashed on a bookshelf and forgotten about or put into your computer and forgotten about. Some people prefer books and some people prefer electronic formats, so it makes it easy for everybody to have access to the studies and to the paperwork. The coordination of the overcurrent devices where possible, that needs to be part of it. And then the ongoing support from the supplier to maintain the model. Honeywell is not going to go anywhere, and so make sure that whoever you're working with is a company that's going to maintain themselves and be a business for many, many years, because it's easy just to make a quick phone call and update that one line or update that model from a design standpoint, and it saves a lot of dollars in the long run in doing that rather than having to go through and redo your entire study. So a little bit on electrical training. Really, the goal at the end of the day, at least our goal when we go into customers and we train, is to reduce and eliminate electrical incidents where we can. What happens, a lot of electricians that are out there say, you know what, this won't happen to me. I've been doing this 25, 30 years. But we know for a fact that one electrician is dying every day. And a lot of those folks are the folks that say, you know what, I don't need this PPE. I've been doing this 25 years. But it just takes 1 millisecond, a wrong move, somebody before you may have done something improperly, you may not be communicating well with your partner, something could go wrong, and then boom. So electrical training is very, very important. And when it comes to electrical training, what does NFPA 70E really say? They pretty much say electrical workers need to be trained in person every 3 years. Now, one of the things that I argue with on that is the sense that every 3 years seems to be quite a long way away. So what we've done is we've actually put together a refresher course, and it's just a module, interactive module, where folks can log in, and it's an hour long, and they can do that every year in between the 3 years. So sure, we can maintain that 3-year in-person training, but it's important to make sure that our team is sharp and up to date on some of the changes with the standards. OSHA, for example, with Subpart V, a lot of changes there, and it's important that our folks know what those changes are. So those refresher courses are very, very key in the sense that that information will be a nice little way to keep them fresh and up to date on all of the changes. So we'll switch gears a little bit here. We'll talk about product, and then I think what we'll do is we'll be done in about 10 or 15 minutes, and I'll have plenty of time if there are questions. So as we switch gears and move to product, here's an example of a piece of equipment where an arc flash took place. And what's eerie about this is actually an image that was taken behind where the individual was standing. So you can see the major damage to that equipment. Here's another angle here of the equipment, and you can tell this is a 5 kV, 1200 amp breaker. And what was likely happening in this situation is that the individual was racking in or racking out that breaker, because you can see the handle still in place there. This next slide is the same incident, but you can see the arc blast taking effect at this point. The arc blast really is copper. It expands at extremely high levels. And so that copper and debris and heat has made its way all up into the rafters, causing residual damage. You can see how enormous this arc flash actually was. So 3 different angles on that shot. So really what OSHA says, and they've got one example in particular, and I'll just read these 2 bullets. A serious violation occurs when there is substantial probability that death or serious physical harm could result from a hazard about which the employee knew or should have known. In this case, the company exposed workers to serious safety hazards that could cause amputations or electrocutions. And this was all quoted by Jack Rector, who is OSHA's area director in Fort Worth, and this was done on October of 2012. OSHA will not tolerate an employer's disregard for workplace or safety, and in this case, the fine was $172,000. All right, so when it comes to shock, how do I protect my electricians? And I think everybody knows the answer. It's insulated rubber gloves. It's the easiest way. But what people may not know is that these gloves are designed so that electrical workers can actually go out and grab a hazard. Most of the personal protective equipment that we manufacture and most of the PPE that's out there is, fall protection, for example. If you fall, this fall protection is designed to save your life. Hearing protection, if there is loud noise. Maybe hearing protection may not be a good example, but in regards to insulated rubber gloves, you are grabbing hazards, and that is what you're doing in your day-to-day job. So it's very important that these gloves are taken care of to the highest degree. So first and foremost, how your team would actually size themselves is pretty simple. Take a measurement around the palm of your hand. If you're a size 8, guess what? You wear a size 8. If you're a size 9.5, you wear a size 9.5. So pretty simple as far as measuring your team for the proper gloves. Some people are a little fuzzy on the testing requirements, and this is right out of OSHA, or ASTM F496, Section 7.1. You can see that in parentheses at the bottom. But any gloves that are issued into the field need to be tested by a certified glove lab every 6 months. And if you happen to be more on the utility side, or maybe even the fact you wear electrical insulating sleeves in the field for some commercial industrial applications, that requirement would be 12 months that they would need to be shipped off to an electrical testing lab for testing. Gloves and sleeves that have not been electrically tested but not issued shall not be placed into service unless they have been electrically tested within the previous 12 months. So that second bullet, really what it's saying is, at the end of the day, if you buy a pair of gloves or buy a pair of sleeves and you store them, you can store them for up to 11 months and 29 days or whatever, 30 days. But as long as you put them into the field prior to that 12-month mark, you're okay. If it exceeds the 12-month mark, then you've got to have them retested before they can be issued into the field. Looking at this next slide, how do you maintain, how do you care for these rubber gloves? Well, first and foremost, each and every time you put the insulated rubber gloves on, you've got to make sure you're checking for cuts, punctures, ozone, corona, embedded foreign materials. We work in a world where there's a lot of metal parts and metal pieces that can really cause some damage to the gloves. There's fragments of metal shavings, things like that could definitely cause some damage. So pay special attention to that, and have your team pay special attention to that each and every time they put the gloves on. They should be doing this field test. You want to look for oil markings. Oil is it really does have some damage that it can do on rubber molecules, and it can break down the rubber. So make sure you're looking for oil markings. And then any gloves that leak air. You just want to roll up the cuff enough to inflate the fingers and listen for any air that may be leaking out. If you hear air, see air, feel air, toss the glove, because you got a glove that could potentially leak energy, and that is obviously not safe. After the insulated rubber gloves go on, you want to make sure you put on leather protectors. That is very, very key, because the leather protectors will protect your insulated rubber gloves, and that's really your heartbeat there at the end of the day for working live. So always wear your always wear your leather protectors on top of your insulated rubber gloves. So, I've got a lot of questions recently with arc flash and how it relates to insulated rubber gloves. So I've got a couple bullets here that may address that for some of the folks on the phone that may be inquiring. But NFPA 70 requires that voltage-rated gloves and leather protectors must be worn in the presence of voltage. But really, today, NFPA 70 does not discuss arc ratings for the gloves. Now, NFPA 70 does say that leather gloves offer good arc flash protection. Well, what does that really mean? So Salisbury took it upon ourselves to do an independent study, and we tested our insulated rubber gloves, and we also tested our leather protectors. So as you can see, what we were able to find is that based on the class, and so if you look at the class 00, which is a 500-volt glove, and black, the ATPV, or the cal rating there of that glove, is 20 cal. And then the funny thing is, if you go to red, it drops a little bit. So you get actually better arc flash protection with the darker colors. It seems that way anyway, based on our study. But at the end of the day, if you're wearing that leather protector on top of the insulated rubber glove, the leather protector will typically always get about 25 cal protection. So if you mix in a leather protector and a red, black, yellow glove, you're literally almost at 40 cal based on the combination there. So you're going to have enough protection in most instances if you're wearing the proper PPE. So again, we recommend wearing a Class 2 glove for HRC 4 and above. So you would have plenty of protection there, barring shrapnel, things like that. And then for hazardous category 3, 2, 1, the combination of the insulated rubber gloves and the leather protector will give you enough protection. So I'd be happy to provide this study or this chart out. It's definitely public information that I can share if anyone is interested. So I'll step into face shields here real quick, but all of the face shields that you buy out there, just make sure that they're meeting ASTM 2178-02. There's another ANSI standard that it needs to meet. You've got to make sure it meets the same criteria for the ATPVU rating given to the garments. So what you don't want to do is buy a hazardous category 4 suit and then buy a hazardous category 2 face shield, because unfortunately that face shield is not going to be strong enough to protect the individual's head in case of a HRC 4 arc flash. So just make sure your face shields always match up with the PPE and verify with that with obviously the labels that may be on your equipment, so you know exactly what your levels are that you're working with. And people ask sometimes, how do I maintain them? Well, I would always keep them in the bags so that way you avoid scratching. And if you need to clean them, clean them with mild soap, mild water. In regards to the PPE, here's an example here of the hazard risk category 2. Skip down here. There we go. So this is an individual in hazardous category 2. You can see the face shield. NFPA 70 actually says for hazardous category 2 that there must be a balaclava worn underneath the shield. So you can see in this instance the individual is wearing that balaclava. And then if you'll look at hazard risk category 3, which is the next slide, this gives you that example where we start getting into the beekeeper hood at that point. And that's really that 360-degree protection that's required. And then hazardous category 4, really the same look, again, that beekeeper hood. But at this point, you're talking about more layers, more protection given to the wearer, because we're talking about much more energy. So, at the end of the day, NFPA 70 provides choices for selecting the PPE. And there's different ways to go about doing it. Some I agree with, some I don't agree with. But, you can always go out and buy software. There's Easy Power, there's Duke Flux, there's ETAP, there's SKM, and do the study on your own. You can always refer to tables, IEEE 1584. NFPA 70E has come out with some hazardous category classification tables that can help. But any way you go there's still going to be a little bit more work on your end in order to get some of that information so you can match up the tables, or so that you can match up the right information required for the software. Now, we also have customers that say, you know what, I don't really want to spend the money, so I'm just going to buy the 40 cal suit option for my entire team. And I really strongly don't recommend that, in the sense that what happens is you're putting your team in potentially arc flash PPE that may not be suitable for what they are working on, and they're just going to be miserable to be open with you. They're going to be extremely hot, and again, they might be wearing the levels of protection that just way over exceed the equipment. So that kind of just defeats morale and kind of pushes down productivity at the end of the day. So doing the study is a very, very good thing. So that way your team knows exactly what they need to be wearing for what applications. And if you do the study, there's a very good chance that really all you need to do is put your team in an HRC2 daily wear. They can wear that from 8 to 5. It's very, very comfortable. And then when they get into the environment where they cross a boundary with a label and they need HRC2 protection, all they've got to do at that point is put on the gloves and the face shield, and folks really, really like that as well. So again, the study is very important so you know exactly what your energy levels are. Here's an example here of what the labels look like. I think we talked a little bit about that, so in the essence of time, I'm just going to kind of move along. There's other product that we have out there that's available. This is a great product in the sense that it's clear, and it's 7,500 volt protection, and it's a blanket. So if you're working on a cabinet of some sort, you can actually cut a piece of this blanket, potentially use magnets to keep it in place. You can actually cut a square out from the inside of the blanket if you'd like, so everything's insulated just around that working area. there's a lot of flexibility in how you can use these blankets that you can actually cut right off the roll. And they're reusable to a certain extent. I would definitely do a visual inspection, though. Once they get a little worn or there's some markings on it, I would just toss it out and get a new piece. Insulated rescue hooks are very important to be placed anywhere you've got electrical equipment. If you get somebody that gets contracted onto that electrical equipment, this is your way to pull them off, because a lot of people have the tendency just to go grab them immediately, and now they're part of that current, and now they're part of that shock hazard. So these are insulated sticks that insulate the rescuer when they remove an individual from that situation. It's important to have them close by that equipment. And finally, the last product that's very, very important is insulated tools. You know, we've talked about the PPE in the sense that you've got the arc flash face shields, you've got the clothing, you've got the gloves, but tools are very important as well. So there's a lot of information you can find in ASTM F1505, OSHA 1910.333. We test our insulated tools to 10,000 volts, but the max use in the field is 1,000 volts. And I would encourage, whether you buy our tools or even outside of our tools or any competitor, just make sure that the tools you buy have that double triangle on them. That is very, very important. That means that this tool has been certified by IEC, and it is suitable for live working. I've seen insulated product on the market that does not have that double triangle, and it makes me nervous and my stomach starts to churn. So just verify that that is the case for the insulated tools that you're buying. And the very last slide I have for insulated tools really just kind of sums it up. Out of NFPA 70, it's 130.7. Employees must use insulated tools and or handling equipment when working inside the limited approach boundary of exposed live parts where tools or handling equipment might make accidental contact. And then in summary there with OSHA 1910.335, which I think we've referenced quite a few times on this call, when working near exposed energized conductors or circuit parts, each employee shall use insulated tools or handling equipment. So I think that kind of takes me to the very end, and I'm going to turn it over at this point to our moderator if you'd like to have some questions.
Great. Thank you for that fantastic presentation, Brian. Before we dive into the Q&A, I want to remind everyone of the short evaluation survey I mentioned at the top of the hour. I'm pushing that out to everybody right now, and it's just a survey on your thoughts. We ask that you complete the survey because it gives us a better idea on what you'd like to see in future webcasts, which improves our future webcast. So I hope you take the time to fill out the survey. If you don't see the survey on your screen, make sure your pop-up blockers are turned off. Okay, now let's get to some questions. We have a lot of questions there. We'll try to get through as many as we can. And Brian, I want to start with training, electrical training. You mentioned earlier that there's an in-person, there's a requirement for in-person training every 3 years. But you suggested, that's a long time, that there should be some other training along with that. So when we're talking about training, whether it's in person or on a computer or what have you, how often should employers be providing training for their electrical workers?
That is a fantastic question. Again, NFPA 70 says every 3 years that electrical workers need to be trained, and that's in person. And I think what they're saying is that is the minimum. Now, a lot of companies I've worked with say that's not going to work for us. We really want to take that to the next level and at least put some type of refresher course in every year. And I love that because these standards are changing constantly. You've got some updates coming from OSHA with Subpart V. You've got some updates that are coming out from NFPA 70 very, very soon, most likely. So, that keeps our electricians that are out in the field fresh, up to date. So my personal recommendation is at least every year, but that really is up to the company, and that should be something they incorporate into their written electrical safety program at the end of the day. That's a very good question.
And again, just to reemphasize, that in-person training, that's in the NFPA 70E, correct?
That is correct.
Is there any sort of OSHA requirement regarding in-person training?
I believe in Subpart V, great segue literally there, because I believe in Subpart V there's going to be something written about training. I've got to get a little bit more clarity on that because, again, that came out April 11th. And our follow-up after meeting with Bill Perry in D.C. on Tuesday is that we're going to be setting up some time with David Wallace to review it, because what we want to do is make sure we're educating our customers on what this Subpart V is all about, and maybe put some type of a cut sheet together that kind of summarizes all of the changes. I think that'd be the easiest way to get some of this information out rather than sending it to somebody and saying, here's 473 pages to review. So hopefully we'll be seeing something like that very soon, and we'll be sending that out to our customers. But I believe that's captured by OSHA in the Subpart V update.
Okay. I want to talk a little bit about gloves, because you spent a good portion on that, and we had some questions regarding some gloves. Is there a standard for what the cal rating of insulated rubber gloves should be? Do you have any comment on that?
Yeah, NFPA 70 really does not address it. The only thing that they do say is that you've got to make sure you wear leather protectors. And, again, the leather protectors will give you a protection of about 25 cal. So if there are questions and you want to verify that information, I'm happy for anybody to reach out to me, reach out to anybody on the Salisbury by Honeywell team, and we'd be happy to share that data that I went through about 10 slides, 15 slides ago to make sure that you understand exactly the gloves you're wearing and what that ATPV level actually is, if needed. So happy to share that information.
Okay. And how long do insulated rubber gloves last? I know that you mentioned earlier, you should always test them and take a look at them before you wear them for work. But is there any kind of general lifespan for these gloves?
That's a fantastic question, and one that I get often. So I would answer that in the sense that it's up to the user on how well they care and use those gloves. So somebody that keeps them out of direct sunlight, we've got folks that maybe take a lunch break and they throw their insulated rubber gloves on the dashboard of the truck. And if you're in Phoenix, Arizona, those gloves probably aren't going to make it 6 months. So if you're keeping those gloves cool, safe, in a dark place when storing them, things like that will really help the lifetime. I've seen gloves in the field for 20 years, but I've also seen gloves fail after that first 6-month period. So it really does vary on how well people are caring for them in the field, really. Good question.
Okay. Now, the term high voltage is used quite a bit, and it's thrown around, and it's seen on various panels and so forth. At what voltage is considered to be high voltage?
That is the important, and that's a very, very good question. That is the importance of doing the electrical assessment, to understand exactly where the dangers are in your facility. For example, we may do an electrical calculation on a piece of equipment that you may not view as hazardous or even high voltage, and then the arc flash rating or the cal rating may come back, ATPV level may come back and be 90 cal. We just don't know until we put all those variables into the calculator and have our engineers go to work on it. So, I can't answer that question unless we actually have all the data supporting exactly what makes up that piece of equipment. But something to very much pay attention to.
Okay. We have a lot of questions dealing with voltage and amps, and I'll try to go through some of them. And here's an interesting question that I saw. A 9-volt battery or 9 or 12-volt energy sources, do those pose any real risk of electric shock?
Yeah, I think that question has come up in the past. I've had an engineer actually answer that question. And based on the voltage, the answer is typically no. And the reason is OSHA and NFPA 70 both have written in their standards and in their publications that nothing is really recognized unless it's 50 volts or more. Now, a lot of people look at 50 volts and they're like, well, that's not really a lot either. But anything below 50 volts is not really even recognized by OSHA or NFPA 70E. So something at the 9-volt level, if that's all you're working on, you're probably going to be fine. And there's nothing per OSHA, there's nothing per NFPA 70E that's mandated to be worn as far as electrical PPE goes, if that does answer the question.
Okay.
Yeah.
We had some questions here regarding some electrical panels. At what voltage or amps would FRPPE be recommended when working on an electrical panel, such as panels with circuit breakers in a facility or house?
That's a very good question. I would say if it's a house, that would take us down the residence path. So typically there's not going to be enough amperage, enough voltage to worry too much about. The arc flash, can it happen? It can, but typically you're not going to have large machines that require that additional current within a house that would allow that to be extraordinary. Now, within a facility or a manufacturing plant, that's where you want to make sure you're paying attention. And unfortunately, I've got to go back to the way I answered the first question. Unless our engineering team understands, or unless the end user or customer knows what those variables are, and I'd gone through them, and there's about 8 of them, the current and the arc duration and all that. It's not really feasible for me to say what the dangers and what the overall ATPV levels could be unless we knew that information. So again, that's the importance of doing that electrical assessment.
Okay. Yeah, there's another question touching on something that you said before. You mentioned, if we're recalling correctly, that assessments can be done by one's own self. But do states have certain statutes that require the assessment to be performed by a registered engineer? So would you have to, if you do your own assessment, you'd have to be a registered engineer depending on the state, correct?
Yeah, that's a very good point. And Mark Moya is with Honeywell. He asked that question. That's a very good point. So there are registrations, there are licenses that are needed. So typically when you've got somebody in-house that's doing an electrical assessment, they probably already have those licenses. They potentially are a professional engineer or a PE anyway, and those are the individuals that would typically do that internally. I think what's happened in the past with customers that do make an attempt for it, they don't realize how much work would actually go into not only gathering the information and the requirements to be able to put it into the software or into the table, what have you, but also the credentials of the individual that would be needed to be able to make that happen. So that's a very good question.
Okay. What are the electrical safety and arc flash liabilities and responsibilities for, say, a manufacturing company that has an outside electrical contractor coming in to do the work on their site? Is this solely the responsibility of the contractor, or are there responsibilities that the company itself that hired the contractor has?
That is a fantastic question, and the answer is the liability falls completely on the owner. And I know that's a little scary, but any electrical contractor that comes onto your site, the owner is liable for their work. Now, something that OSHA is addressing within Subpart B, and you'll see those changes coming out very soon. As I said, they came out April 11th. One of the high-level bullets that they're addressing is that not only will this continue, but they're actually going to mandate that the owner or the company actually provides training for that contractor. And I really like that in the sense that that'll cause some true alignment there with any contractors that do come on site, because it's important that the contractors do their end of the work too, where they're following all of the procedures that the employee or the organization has. So if the contractor is able to meet all of the employees' policies and procedures and things like that, and they're well educated on it, that lowers the risk of anything going wrong, obviously.
Okay.
Good question.
You touched on quite a bit about the arc flash hazards. How does one go about recognizing a potential arc flash hazard in the facility?
That's a good question. I think that goes back, unfortunately, and I hate to keep going back to the assessment, but until an assessment is actually done, we don't really have clarity on what the energy levels are and what the hazards are within a facility. And the electrical assessment will allow all of that information to be printed, not only electronically but in a book, and then also labeled throughout your facility. So every electrical person or non-electrical person understands the hazards of what that equipment is capable of producing. So I hate to go back to that that electrical assessment again, but that is why those are so important to do.
So it sounds like assessments really are the key to just about everything when it comes to electrical safety then.
Yeah, I would say that's a very, very important step. Yeah, absolutely.
Okay. All right, great. Thank you. Unfortunately, we have run out of time. I apologize. There are numerous questions that have been asked that we didn't get a chance to address here today. But don't worry, all of these questions are going to be forwarded on to Brian. So once again, I thank you, and I hope you take time to fill out the evaluation survey on your screen and give us your feedback. And with that, we are going to conclude Safety and Health's magazine webcast. I'd like to thank Brian, Salisbury by Honeywell, and all of you who listened in. Thank you, and have a wonderful day.
Thank you.